Well, hello, 7th grade. This is not what I want you to be looking at. I want you to be looking at that. L87, multiplying algebraic terms. So not too long ago, we had a little lesson on just algebraic terms, what they mean. We talked about monomials and binomials and trinomials. And we basically looked at just the concept of simplification, and this is going to be similar because these will, I guess the one word direction here could be multiply, but it might also say simplify. And simplify this basically means like do the math, make it less. So given this, and please write it down, where we have negative 3x squared y being multiplied by 2x being multiplied by negative 4xy, we want to turn our brain on. We want to make careful choices. And when I have both variables and numbers in a multiplication situation like so, I'm always going to think about numbers first. And when I think about numbers, that just has to do with me knowing how to multiply numbers, but also, as something that we would have looked at last year and also this year, just that concept of like signs, unlike signs. We looked at not too long ago that we can count the negative signs to determine whether something will end up positive or negative. So when I consider that I have to multiply this negative 3 ultimately by this 2 by this negative 4, if I take that time to think about the negative signs, I have one there and another one. Now that's 2. And 2 is an even number. So we know the end result of this, the product of the numbers will be positive. And then again, it doesn't really matter which order I go. I can go backwards. 4 times 2 is 8 times 3, which is 24. Or I could go forwards. 3 times 2 is 6 times 4, which is 24. I could, any other way? Oh yeah, I could jump over. 3 times 4 is 12 times 2 is, guess what? We're at 24, people, no matter how we swing that thing. All right, now's where really our new thinking has to take on. And this is what I always refer to as the exponential rules. And so then, after you've dealt with your numbers, we want to apply any exponential rules at play. Do you recognize the one that would be at play here? Oh, well done. The multiplication of powers with like bases. Let's just review that real quick by writing them down. So when we show that algebraically, we say this, that a to the m times a to the n. Now remember, that's multiplication of powers, and they both have the same base. Do you remember what that equals? I hope so. And just by the way, I posted not too long ago your exponential rule sheet. If you haven't printed that up and maybe put it in your folder for easy reference, I would suggest it. This stuff's going to keep coming at you. So a to the m times a to the n is simply a to the m plus n. And we have that situation going on here, because ultimately everything here is being multiplied. And if I focus in on the x, or the x's, I have an x squared right here. I have an x here, and I have another x. And those are all being multiplied. They're all powers. They all have the same base, the base of x. Remember, when applying this rule, don't forget about sneaky ones. So what would x squared times x to the first times x to the first be? Yeah, nice. X to the 4th. Don't forget about your sneaky ones. They're really important. Is there more to do? Yeah, because we still have the y to deal with. So I look and I go, okay, I've got a y. I've got a y here, and I've got another y. Sneaky ones? Yeah, they're there. So y times, what would y times y be? Oh, you should know this. It'd be y squared. We've been exploring that idea for a while, huh? And that's it. I get to box that up. Fully simplified, yeah? Let's do more. Please write it down. I've got negative 2ab times a squared b times 3b cubed. Remember what we said. Numbers first. Numbers first. Always just deal with your numbers. So what do I got? I got a negative 2. I got a positive 3. That's unlike signs. Unlike sign multiplication always results in a negative. And 2 times 3 is simply 6. All right, now what rules at play here? Is it the same one? Yeah, it is. So let's focus on our a's and our a squared. Multiplication of powers with like bases? Sure is. What do? I add the exponents. What will that be? Call it out on 3, everyone. 1, 2, 3. A cubed. Or a to the 3rd power. That would have been fine as well. Good job. All right, now let's deal with the b's. So I've got a b here and another b here and a b cubed here. Is that multiplication of powers with like bases? Yes, it is. So what am I going to do? All right, count of three. I want to hear you call it out. I'm all the way in Sherman Oaks. I want to hear you yell it loud so I know. B times B cubed on the count of three. 1, 2, 3. Wow, that was loud. Well done. B to the fifth. Live and in stereo from across the city. I am proud. Let's box it. Yeah? Una más. Let's look at this situation. So I've got negative 3a squared b cubed raised to the second power. Now, we always deal with numbers first. I do want to consider those numbers, but also right now, I don't have anything to multiply that number by. So I have to think about, well, what exponential rules are at play? A squared and b cubed, those are being multiplied, but they're not like bases. It's definitely not division. So there's actually two rules. Can you name one of them? Go ahead. Nicely done for the sticker. I didn't think you'd pick that one, but yeah. So there's this rule. It's called raising a product to a power. And this is the rule that I always explain is, you know what, I think people would just figure this one out. They naturally know. But the way that raising a product to a power goes is something like this. So we'd say A, B, that's a product, right? They're being multiplied. And if I wrap that in parentheses and I put raised to the M, what I know is that this M is going to get applied to each factor inside. So I would say, okay, well, AB to the M is equal to A to the M times B to the M. So that M gets applied in, yeah? So that's what we've got going on here with this 2, right? This 2 is going to get applied into everything. So let's deal with our numbers first. So let's write that out. Negative 3, so that little 2 is going to get applied to the negative 3. It's going to get applied to the a squared. It's going to get applied to the b cubed. So we want to write out, and parentheses are very important here. I know I've talked about the nuance. You have to be responsible to this. We're going to write negative 3 in parentheses, and we're going to square that bad boy. We'll hold off on that for a second. Now, do we still have raising a product to a power? Yeah, it has to apply to the a and the b, but here's where the other rule comes in. Anyone for the sticker? Good job. I'm so proud of you all. Really? Okay. This one's called power of a power, and you just called that out, so you know. And power of a power is shown in this way. So we'd say, okay, A to the M raised to the N. Do you remember what we do? Good job. Yeah. So we're going to multiply that. A to the M times N. And that's how it works, right? That's how those end answers work. So if I think about this a squared, that 2 gets get applied. So I'm going to multiply those exponents and end up with, yeah, of course. So this a squared to the second power going to become a to the fourth. Good job. All right, let's do the same thing with the b. So b cubed to the second power, power of power, right? We're going to multiply those? Yeah, we are. B to the sixth. Now you're going, so we box it up. Well, the whole thing is that we are expected to fully simplify. And so it's that negative 3 to the second power that we have to think about. So what does that mean? I often talk about meaning with exponents. And just like 6 to the second power means 6 times 6, what does this mean? Well, wouldn't it have to mean negative 3? Negative 3 times negative 3? Yeah, it sure would. And I kind of expect you to be able to handle that. Is it like sign? Is it unlike sign? Yeah, good. Like sign. The end of like sign is always what? Positive or negative? Yeah, positive. So negative 3 squared is simply 9. Nothing's changing about this a to the fourth or b to the sixth. And so I get to box that up. You might go, oh, okay, all right. Hey, this stuff gets pretty, they start to lay it on kind of thick. Maybe I'll send you a picture of a problem that ultimately, yeah, I would want you to be able to do it. It's all about applying those rules, but numbers first. Numbers first, then deal with your variables. Hey, let's get back here. L87, multiplying now algebraic terms. Hopefully this went okay for you and that you're doing okay. I do have regular homework for you. It's called Homework 87. I bet you could have guessed that, though. Take good care. Reach out to me if you need me. Bye-bye.